Let's have a look together at how we can use linear splines to create a semi-decent model for the simulated data we looked at the beginning of this week. Simulate the data again. I've just over here put independent numeric variables and the ones that we want to create a spline from. I'm doing this to try and help you that when you try and apply this to the Amy's house pricing data for your week 3 assessment, that you can kind of use this code as a starting point. Now, the first question is, where are we going to create these splines? If you have age, which we did when we were looking at the motorcyclists, we could look at the data and we decided in advance we'd have a spline at age 20 and age 35 because that looked right from the data. But we don't really want to have to do that. It's not necessarily the right thing to do in any case. Far better just to split any particular variable feature that you're looking at by a certain number of percentiles. Let's say we want to split it into 20 percentiles. Well, let's think how we might go about doing that. Here are the numbers 1 through to 20. If we multiply them by 5, we'll have 5 through to 100. And let's say we're going to take our variable x, which is df train, finally, we'll call the numpy percentiles function. So we're going to split using numpy percentiles function our train data into its percentiles, 20 percentiles. Right, that didn't work. Percentile. Better. There you have it. Well, if you remember, the data was simulated from between 0 and 1, so that sounds about right. Let's store these percentiles because we're going to need them. Let's create a data set to store our results. df p-tiles, we'll store the original variable that we're working with. This is quite a convoluted way of doing this, and the reason I'm doing it this way is so that you will have a function to use later on. So I'm going to call a variable. Var is the variable we're working with, which is going to be x1 all the way through this. And actually I'm going to store the values for our variable. I'm just trying to take this halfway to actually being a function. What do we have? Variable x underscore 1, the actual values that are in this variable. Here are the percentiles, and finally a data frame which contains the original variable and the original values. And now let's add the linear splines. This is the variable name, which is going to be the original variable name, plus the percentile index. And what is this going to be equal to? Well, if you remember, the way we create our splines are to take the greater of 0 and the variable value minus the naught. The naught is going to be the percentile in each case. Let's have a look at the data we just created. If you remember, each linear spline is defined by a naught. To the left of the naught, the value is 0, and to the right of the naught, the value starts sloping upwards. The naughts we have defined are the percentiles, so the naught for this particular first linear spline is 0.1056. You can see that the original value here was 0.104, which is less than that, therefore it takes a value of 0. Whereas if we go down a little bit, the original value here was 0.306, and therefore we take the greater of 0 and 0.306 minus 0.105, which is 0.207. I'd recommend you really stop and think at this particular stage, go through the video again, make sure you understand how these numbers are being derived. What I'd like to do now is for your sake really, just to turn this into a function which you will be able to cut and paste into any work you do. Right, I've just spent a little bit of time typing this up. Let's see what we've got. First of all, we have a function which takes a variable name and the values of that particular variable, or a feature name and the values of the feature. It's pretty much hard-coded in here that you're going to look at 10 percentiles. The first thing you do is create data which contains the original variable and variable name, and then you add the linear spline for each of the 10 percentiles. Finally, you return the data set and the percentiles. In order to add these linear splines to any data set, we're going to add it to df_all, which is the full data. That's not really good practice, but we won't worry about that right now. My Mac's about to run out of battery. Time to pause the recording, get back to you soon when I've got a power lead. Okay, I'm back. I kind of find it quite bizarre that you buy a brand new Mac and it advertises itself as saying battery will last all day long without any recharging or something like that. And that is totally true, so long as you don't use your machine for anything, so long as you just open it and stare at the screen. The second you start using it for something like anything, Python, rendering video, it lasts for about 10 seconds. Anyway, where was I? I think we've got as far as the fact that especially if you're in Amy's house pricing, something like that, you're going to want to iterate through all the variables that you want to turn into a spline, which will be those that you suspect might have anything besides a linear relationship all the way through their range. For each one of those, you will pass to your splines function the variable name and the variable values. You can stick values after there if you wanted, I suppose. Then you will drop from your original data that particular column, because you're about to add it along with all the linear splines. You'll also remove from your list of numeric variables that variable name, because it will be included in your splines. And then finally over here, df_all, your original data set will now be made up of your original data set plus all those linear splines, including the original variable. Finally, you will extend your numeric independent variables by all the variables in your new data. There's probably a much better way to do that, but at the end of the day, if you run that over your Amy's house pricing data, so long as you've defined all of your numeric variables first, and those of your numeric variables which you wish to turn into a spline, it's going to do it for you. What I would say is that if a numeric variable has less than 10 unique values, this piece of code will probably fall over. I think the laziest thing you can do is to only turn into a spline something that, say, has 20 unique values or more. Okay, now we've done that and run it. This is our new data. We have the target variable. We have the original X variable that we simulated, but we now have a load of new features, hopefully 10 of them, each one of which is a linear spline which stays flat up until a certain point and then starts sloping upwards. We should recreate our train and test data over that. Finally, we can do ridge regression. We're going to define our variables, which is basically every variable, so long as it's not y, create our x and y data, and do a ridge regression. We're going to move on to H2O next week, but right now I really want to stick with sklearn, but I have to say sklearn seems to be annoyingly bad at some of the default assumptions it makes for cross-validation. It's certainly true in its default choice for the range of lambda that it tries, which it calls, annoyingly, alpha. So I've done something here to choose the alphas myself. It fits very quickly. Let's graph the resulting model. Well, there you have it. I can't say it feels like a great fit, but the one thing you can tell is that this fit is made out of straight line segments. Can you see how it literally goes around the corner using a series of straight lines? It's hard to blame it for fitting a straight line through that last bit and not using any of the linear splines that it had available to it, because that does kind of look like could be a straight line. If you look at the result on the test data, it's not great, one has to say. But there it is, that's how it works. I am curious if we would have allowed it slightly more splines, if it would have done better. So I'm just quickly going to go up here and change it to 20 linear splines. I'm going to reset the workbook, clear all the cells, and run through everything quickly again. Interesting. It does seem to do better this way. I guess it needed a certain more flexibility in that particular region. Within reason, you should be able to use more splines because you're using penalized regression. It should chuck away the ones that it doesn't need. There you are. I've tried to illustrate how to use splines. It is difficult. It is confusing. So what I've done, I've written these 2 bits of code to you, these 2 bits of code for you. This week's coursework is going to ask you really one last time using scikit-learn. You're going to be using ElasticNet, revisiting your one-hot data, but this time adding linear splines to at least some of the numeric variables and to see how well you can do in predicting house prices. Any questions, as always, post them on Moodle. Good luck with the assignment.